In the second part of 5.2, we'll continue with our study of definite integrals. So let's take a look at some of the terminology and notation of integration. And we can see here we have our integral symbol, and a is considered our lower limit, b is our upper limit, f of x is the function that is being integrated, or we call that the integrand, and x is the variable of integration. Okay, the way we read this is the integral from a to b of the function that's given in the problem. Okay, and basically the definite integral really is calculating the net area under a curve over a given interval. The existence of definite integrals: all continuous functions are integrable. That is, if a function is continuous on an interval a to b, then its definite integral over a to b exists. Now, we talked about signed area. If we are going from, in this example, say from 0 to 1, notice that that area is all above the x-axis, and we would consider that to be positive area. Same thing in graph number 2, okay? That area is all above the x-axis, so that is considered to be positive area. In the next couple of pictures, notice that all of the area between the graph and the x-axis is below the x-axis, so we would consider that negative area. Now, when you have some area above and some area below, the definite integral is basically the accumulation of all the areas. So this would be considered positive area, the green part, and the pink part would be negative area. So you would combine those two, and if there's more negative than positive, your net result will be negative. And you can see in this diagram, the answer to this one is negative 0.151516, which means there's more negative area than positive area. Okay, let's take a look at an example. We're given this piecewise function, and the graph of the piecewise function is provided, and we want to find the integral from -5 to 2 of f of x dx. Okay, so we're going to have to break this up into a couple of parts. The first thing I'm going to do is I'm going to find the area of this rectangle, which will be positive. Then there'll be the area of this triangle, which will also be positive. Then the area of this triangle down here, which is going to be negative. And then we have some more area up here that is positive. So to figure out the integral from -2 to 5 of f of x dx, you're just going to calculate the area. So the area of the rectangle, my length is 1, my height or width is 2, so it's going to be 2 times 1, plus the area of this triangle is going to be 1/2, the base is 1, and the height is 1. Then I'm going to subtract, because it's negative, 1/2, the base is 2, and the height is 1. And then I have plus another triangle, 1/2, base is 2, and the height is 2. So if we work this out, I get 2 plus 1/2 minus 1 plus 2. So this ends up being 2 plus 2 is 4, minus 1 is 3. 3 and 1/2 would be the integral from -2 to 5. So the signed area of the area under the graph would be 3.5. Okay, let's try this one. Now we're going from -3 to 5. Again, we have another piecewise function. So this part here would be considered positive area, the triangle. And there would be a negative triangle under there and a rectangle under there that would be negative. So to find the integral from -3 to 5 of f of x dx, this is really going to equal, my triangle is 1/2, my base here is 3, my height is 3, minus this triangle, which is 1/2, the base is 1, the height is 1, minus the length is 4, the width is 1. So this ends up being 9/2 minus, this is going to be 1/2 minus 4. So this ends up being 9/2 minus 1/2. If I change 4 to halves, is 8/2. And this works out that my net area is 0. Okay, so basically the definition, area under a curve, if y equals f of x is an integrable function over a closed interval, then the area under the curve from a to b is given by this integral. So again, this area is simply the integral from a to b of my function. So say we're asked to evaluate the following integrals, and we're asked to find the integral from -2 to 2 of the square root of 4 minus x squared. Well, the first thing we need to do is we need to draw a picture of this graph. And if you recall from our study earlier in chapters 1 and 2, this is the formula for a semicircle, and the semicircle has a radius of 2. So I'm going to make this 1, this 2, this -1, this -2, this 1, and this 2. So my graph is going to look something like this. So now to find the integral, we have to calculate the area of this semicircle. Okay, so the area is going to be 1/2 pi times the radius squared, plus 1/2 pi. The radius is 2 squared. So this is 4 times 2. So this is 4 times a half, sorry. So this final answer would be 2 pi. So the integral from -2 to 2 of the square root of 4 minus x squared equals 2 pi. Okay, in our next example, we have the integral from -3 to 6 of 2x. And 2x is just a linear function. So I'm just going to go to a bigger graph here. So we have the function y equals 2x. And if I made a table of values, my table of values is going from -3 all the way up to 6. So I'm going to plot 3 points. So if I put -3 in, it's going to be -6. If I put 0 in, it's going to be 0. If I put 6 in, it's going to be 12. So -3 and -6 is going to be about right there. 0, 0, and 2 and 12. Not 2 and 12, sorry, 6 and 12. Okay, so now if I join those, I get a straight line. And we're asked to find the integral from -3 to 6. So we're looking for the area. So we have a triangle that's below the x-axis. And I also have a triangle above the x-axis. So this second triangle would be considered positive area, and the first triangle would be considered negative area. So the answer to this integral is going to be -1/2. If I look at my graph, the base is 3 and the height is 6, plus 1/2. Oh, sorry, I'm going the wrong way. The base is 6 and the height is 12. So this ends up being 18 times -1/2 is going to be -9, plus 36. And this works out to be positive 27. So for right now, the only way we can calculate a definite integral is to draw a picture of the function and then calculate the area under the curve. Okay, the integral of a constant. Okay, if we have a constant function and we're trying to integrate it, basically the formula for that is it's just whatever the constant is times b minus a. Now, if you stop and think about this, it makes a lot of sense because if we had a constant function, say we had the function right here, y equals, say, 7, and I'm evaluating the area of the integral, let's say from 3 to 9. Okay, well, that would be a rectangle. And to figure out the area of that rectangle, well, the height would be 7, the length would be 6. So it would be 7 times 6 would be 42. Okay, so basically 7 is my constant. And b minus a, 9 minus 3 is equal to 6. So that is why the integral formula for a constant is simply the constant times the difference in the lower limit and the upper limit. Okay, we can also use our graphing calculator to evaluate definite integrals. Okay, so let's take a look at how we do the first one, the integral of -1 to 2 of x sine x. Okay, so if we go to our calculator, we're going to go to calculate, and right beside the number 9, there is this button right here that brings up a lot of our functions, and I want the definite integral. Okay, and this one I believe is going from -1 all the way up to 2 of x times sine x. So it's going to be x times, again, you don't really need the times if you don't want to, but you can put it in there, x times sine, and there's x. And you have to tell the calculator you're integrating with respect to x, and if we hit enter, it'll give me an answer like that, which isn't very user-friendly, but again, now I can convert that. So if I go menu, number, convert to a decimal, and hit enter, it's 2.04276. And again, if we were writing this, we'd round off to 3 decimal places, so 2.043. So this equals 2.043. Okay, so for the second one, we want to do the integral from 0 to 5 of e to the negative x squared. So same process, I hit the integral key, so I'm going from 0 to 5 of the function e raised to the negative x squared, and I'm integrating with respect to x, whoops, not y, but x, and then I hit enter, and that one gives me a decimal answer right away of 0.886. So this answer was 0.886. And the last one, you want to be careful with this one because you have a binomial in the denominator. Okay, so we're going to go back to our screen. Again, remember to clear the screen, I just hit menu, actions, clear history. And now I want to do again the definite integral. And this is 4 over 1 plus x squared from 0 to 1. So 4 divided by, I want to put brackets, 1 plus x squared. And this is going from 0 to 1. And again, I'm integrating with respect to x, and I get an answer of pi in this particular case. So my final answer for this one would be pi. So being able to evaluate integrals on a calculator is an important skill that you're going to have to be able to do. And again, we'll spend a lot of time dealing with that in class, but again, pretty straightforward procedure to do that. Okay, that ends the end of section 5.2. So there is your assignment from the AP Calc textbook. Questions 39 and 40, you will need a calculator, so you might want to do those first in class if you're not taking your calculator home with you. All right, give those a try and see how you do.